All right, so in our last video, we talked about finding the inverse of a matrix, and we're going to learn how they actually help us to solve some systems of equations today. So if you think back to the last lesson, the whole point, or what happens when you multiply a matrix by its inverse, it gives you this matrix here. Anytime you take a matrix like this one, multiply it by its inverse, which is this matrix, you get this matrix here, which we call the identity matrix. And when you multiply a matrix by the identity matrix, so if you take the same one times the identity, you end up with the same one as you started with. So it results in the same matrix, which kind of explains why what we're going to do today is going to actually work. So again, just to recap, to find an inverse, what you do is you take 1 divided by the determinant, right? So our determinant here is 2 minus 4, so it's 1 over negative 2. And then times that by, we switch those two around, so 1, 2, and then we change the sign of the other diagonal. And sorry, I'm writing kind of slanted. Let's see if I can fix myself here. So what we have here is negative a half times 1, so negative a half. Negative a half times negative 4, 2, negative a half times negative 1 is a half, and so on. So we'll be using inverses quite a bit today. So when we have a system of equations, so again, that means more than one equation, more than one variable. We have this matrix equation here where we take our coefficient matrix, so our 2, 5, 5, negative 3, times our variable matrix, so our variables are x and y, and that equals our constant matrix, 0 and 31. So we have this equation where A represents the coefficient, the coefficient matrix, x is your variable matrix, and B is your constant matrix. So you have this equation AX equals B. Well, what happens is we can multiply both sides of this equation by the inverse of A. So we multiplied both equations by inverse of A. Well, what happens, you have the inverse of A times A. Well, when you take a matrix times its inverse, you end up with the identity matrix. And if you take any matrix times the identity matrix, you just get that matrix. So we end up with X, so our variables are going to equal the inverse of A, so the inverse of this matrix here, times our constant matrix. So if we can find the inverse of this, we just multiply it by our B, by our constant matrix, and we'll have our answer. So our coefficient matrix is 2, 5, 5, negative 3. So we got to find its inverse. So first we got to do 1 over our determinant. So we would have 2 times negative 3. So I'll just write the determinant over here. So 2 times negative 3 minus 5 times 5, so minus 25. So we end up with negative 6 minus 25, so negative 31 is our determinant. And to get our inverse, we have to take that times our coefficients. So when we do that, we just multiply everything by 1 over 31. So we end up with, negative 1 over 31, I should say. We end up with negative 2 over 31. We end up with negative 5 over 31. 5 over 31. And 3 over 31. So that's our inverse. So now to get the answer, so we found this A negative 1. To get our variables, to get our x, we just have to multiply times B, which is this one here. So take this matrix times a 0 over 31 matrix. And so you multiply. So remember, we're going to get an x and a y, right? So, or a 2 by 1 matrix here. So we got to multiply the tops and then the bottoms, right? Or sorry, row 1 times column 1. So negative 2 over 31 times 0. That's 0. 5 over 31 times 31, which is 5. And then to get the y, we take the second row times our column. So anything times 0 is 0. over 31 times 31, well, your 31s cancel and you're left with 3. So our answer is x equals 5 and y equals 3. So you find the inverse and you multiply it by the constant. So we'll look at a few more examples. So here's our next example. Already got our matrix equation set up here. So our coefficients here and here, variables, and then our constants. So first we calculate the inverse. So we got to take 1 over the determinant. So that's going to be negative 5 minus negative 2. So negative 5 minus negative 2 is negative 3. And then remember the pattern, we have to flip these two around. So 1 goes here and negative 5. Change the signs on those. So negative 2 and 1. So multiply our times our negative 1/3. So we got negative 1/3 on top 2 times. And then we have positive 2/3 and 5/3. So now that we have our inverse, we just got to take it times our coefficient matrix, or sorry, our constant matrix to get our answers down here. So to get x, take our row 1 times these two. So negative 1/3 times negative 33. Negative times a negative is a positive. And 33 divided by 3 is 11. So I'm just going to write this out. And then negative 1/3 times 12 is negative 4. So that would end up giving us 7. And then if we do the bottom, so 2/3 times negative 33, it's going to be negative 22. And then 5/3 times 12, doing quick maths in my head, that would be 20. So negative 2 there. So we get an answer of 7 for x, negative 2 for y. And if you want, you can always check it, right? Plug in 7, negative 35 minus negative 2 is negative 33. That works. 2 times 7, 14, plus negative 2 is 12. That one works as well. All right, we'll do one more example here. And what you're probably noticing is that everything's not in standard form, right? So write the matrix equations. Let's start with our coefficients. So we have 1 and 1 there. Now here we got to do some rearranging, right? So let's add 3y over, make it 2x plus 3y, and move the negative 9 over, so this becomes a positive 9 here. So we got 2, 3. All right, so the next step, well, let's write out our equation first. So we're finding x and y, and it's going to equal 4 and 9. So to do that, we got to take the inverse of a here. So let's find our determinant. 3 minus 2, 1 over 1. Hey, that's easy. All right. Then let's switch things around. So the 1 and the 3 switch. And we change the sign with the other diagonals. And we take our inverse, because times 1, it would stay the same. Times 4/9. Sorry, I should say the matrix 4, 9. And that's going to equal, so 3 times 4 is 12. Negative 1 times 9 is negative 9. So we get 3. Negative 2 times 4 is negative 8. 1 times 9 is 9. So that would give us an answer of 1. So 3, 1. And again, we can check it if we want. 3, 1 works there, 3, and then a 1, that works there as well. All right, and then finally we'll do a quick word problem here. So first is figuring out the equations. So Silas and Jack are buying pizzas for a party. Silas buys 3 one-topping, 2 specialty pizzas for $38. So let's call the one-topping pizzas X. So he bought 3 of those. He bought 2 specialty pizzas. So we'll let Y represent specialty pizzas. So 2Y for 38. And then Jack bought 1 topping. And he bought 4 specialty pizzas. And that was a total of 41. So, like before, let's get our matrix equation. We got 3, 2, 1, 4 times xy gets us our constants, 38 and 41. So take the inverse, right? So 12 minus 2, so it's going to be 1 over 10. The 4 and the 3 switch spots, make the others negative. So when we multiply that out, we're going to get 4 tenths. And I'm just going to leave it in tenths. You'll find it's actually easier not to simplify until the end. So 4 tenths, negative 2 tenths, negative 1 tenths. This way when we're adding, everything's in tenths, so you don't have to worry about getting a common denominator. There we go. So that times our 38 over 41 matrix. So equals. All right, so here, for this top term, it's 4 tenths times 38. So 4 times 38 is, oh, I better break out the calculator just to be on the safe side. 4 times 38, so that's 152 over 10. Plus negative 2 tenths times 41 tenths, so that's negative 81 tenths. All right, and then we'll simplify the other one. So negative 1 tenth times 38, negative 38 tenths. And then 3 tenths times 41. So 41 times 3 is 123 tenths. So if we simplify now, 152 divided by 10, or actually let's combine these. 152 minus 81, 71 tenths. And then these two together, 85 tenths. So when we're looking at prices, dividing by 10 is pretty easy. So 1 toppings, we have 71 tenths, so that would be $7.10. And for the other one, 85 divided by 10, so specialties would be $8.50. And there you have it. Pretty simple stuff, really. So anyway, oh no, I just noticed a typo. This was supposed to be an 82, which makes that 70, which makes this $7. All right, glad I caught that. All right, so again, pretty simple. To solve these problems, you find the inverse. Okay, so here's our inverse and take it times the constants. Pretty simple stuff if you know how to find an inverse and how to multiply. If you know those two things, then you got it nailed. So assignment to get today again is on delta math. So go into delta math, find algebra 2, and make sure you're doing the 4.5b assignment. There is a due date for that, so get in there, pay attention to that. That's the day after break ends. So hopefully you're hanging in there. I miss you guys. I'm sure the feeling's not mutual, but I do miss you guys, and hopefully we have you guys back in class soon. Take care.